Welcome everybody to Algebra 2, Section 4.7, Solving Quadratics by Completing the Square. So let's review some perfect square trinomials. How perfect square trinomials work is you have your a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And so essentially what happens here is we have two perfect squares that start and end the trinomial, and then in the middle you have the square root of each that is being doubled. And how this always factors when for some of perfect square trinomial where they're adding and the middle term is positive, you have a plus b quantity squared, or a plus b times a plus b. And when it's subtracting in the middle, you have a minus b quantity squared, or a minus b times a minus b. And we see this here on all four of these examples, one or the other, whether the middle term is positive or negative. And so here, on the first one, we have x is the square root of x squared. X times x is x squared, and 2 times 2 is 4. In the middle, we see this here, the 2x, which would be if we multiplied a and b together, in this case x and 2, and then we double it. We would get 4x. And so this means this will factor into x plus 2 quantity squared. Now, if you're like, this is too much for me to remember, I'm going to get confused by this, you're more than welcome to still use the x method, where you would do 4 at the top, 4 at the bottom, get plus 2 and plus 2. But the reason why we are reviewing this right now is because it'll come in quite handy to know this quote-unquote shortcut here for factoring these perfect square trinomials. And so this next one here would be, once again, x times x is x squared. 10 times 10 is 100. And if we were to do 10 times x and double it, we would get 20x. Now with this negative here, that just means that our sign in between them is negative. And so it's x minus 10 quantity squared. Because it's also true that negative 10 times negative 10, if we square that, that would be 100. And 2 times negative 10x would be negative 20x, which is how we know this is negative, once again, because this is negative. So if we look up here at the top right, we see x times x is x squared, 7 times 7 is 49, and the middle is 2 times 7 times x. And so we have x minus 7 quantity squared, once again knowing the sign comes from this term. On this last one here, we see x times x is x squared, 8 times 8 is 64, and if we do 8 times x, and double it, we get 16x. So this is x plus 8 quantity squared. Now, once you have this scenario, a perfect square trinomial on one side, we see x squared plus 14x plus 49, which is very similar to what we saw up here on the top right one, except for the 14x is positive. And it equals another number. We don't have to worry about subtracting 4 and moving it across. Now, we could certainly do that. We don't necessarily have to. And today we'll be learning in order to how to even just create a scenario like this and use that to our advantage to factor problems that may not otherwise be factorable. And so what we'll do is we'll just factor this side as x plus 7 quantity squared is x times x is x squared, 7 times 7 is 49, and if we multiply those two together, x and 7, and double it, you get 14x. And this should equal 4. And now that we have something squared equals a number, we can square root. Both sides undo the square. And that helps us here by saying we have x plus 7, what was inside the square, equals positive negative 2, very similar to how we solved by square rooting before. We just created this scenario this time, instead of being given that scenario like we were previously. And now we can subtract 7 from both sides, but remember, before we do, we have to split it into the two cases, or two scenarios, where you have x plus 7 equals 2, and x plus 7 equals negative 2. And in both of these, you will end up subtracting the 7 and getting x equals negative 5, and x equals negative 9 as our two answers. Number 2, we'll practice the same thing here, where this is also a perfect square trinomial. X times x is x squared, 3 times 3 is 9, and in the middle, if we do 3 times x and double it, we get 6x. It just happens to be negative, so we do x minus 3 quantity squared equals 20. We will then square root both sides. Then the square root undoes the square, so we get x minus 3 equals positive and negative. As we simplify the square root of 20, we see this is square root of 4 times square root of 5, or x minus 3 equals positive negative 2 square root of 5. We'll go and add the 3, which goes before the plus or minus, since it can't combine with the 2 square root of 5 anyway. And we get x equals 3 plus or minus 2 square root of 5 as our two answers. So this leads us to talking about the method which is called completing the square. And we can do this with any quadratic equation where we create a perfect square trinomial even though it's not there to begin with. And this is called, once again, completing the square. We are turning it into or completing something that is a perfect square trinomial, or something that can be a binomial squared, which is what these all end up being, are binomial squares. And so if we start here with this example, we have x squared plus 8x minus 34 equals 0. Not currently a perfect square trinomial. X squared is a perfect square, but 34 is not, for example. And so what we always want to do is rewrite it as ax squared plus bx plus equals c. So I'll need to add 34 to both sides and get x squared plus 8x equals 34. Then, if applicable, which it is not here, I should note that is step 1 here. If applicable, which is not here, then we would divide both sides by a, or every single thing by a. So if there's another number here than 1, such as 2 or 3 or 4 or 1/2 or whatever, you have to divide everything by that number. Once again, we don't have to here, so we're going to go to step 3. Step 3 is where you take half, and I'll move it down to where step 3 would be. We'll take half of b, square it, then add this to both sides of the equation. So b is 8, and if we take half of b, in this case 8 over 2, we get 4, and we square the 4, we get 16. So half of b and square it. So we end up getting positive 16, and what we're going to do is add that to both sides. So we get x squared plus 8x, and I like to write a blank here in this step, equals 34 plus blank. And the reason why we add it to both sides is because when you add something to an equation, if you don't add it to both sides, it's not remaining equal anymore. So we have to add it to both sides, just like we added 34 to both sides a moment ago. The reason we're adding 16, though, is because it completes a perfect square trinomial on the left-hand side, where x times x is x squared, 4 times 4 is 16, and if we multiply x times 4 and double it, we get 8x. So this creates that perfect square trinomial that we're wanting. And so now we factor this into the perfect square trinomial, like I was just mentioning, where it'll always factor into x plus 4 being squared, or the variable half of b, which was 4, the number we squared. And that equals 50 as we just combine like terms on the right-hand side, or simplify 34 plus 16. Now on to step 5, we will take the square root of both sides and solve for both cases. So we have x plus 4 quantity squared equals 50. I'm just rewriting it here. Typically I don't rewrite this step, but for the sake here of showing where we are at step 5, I'll show it. So we are square rooting both sides, and we get x plus 4 equals positive and negative square root 50, which we know can simplify to positive negative square root 25 times square root 2, and is then x plus 4 equals positive negative 5 square root 2. And then it asks us to simplify all irrational or complex solutions, and that's what we're doing here in step 6, is simplifying these solutions, which you always do once again. And this is actually technically both step 5 and 6. It's kind of silly here that there's a step or step 6 for simplifying all irrational or complex solutions, because you do that as part of step 5 where it says solve for both cases. You do that as part of the solving. So it's step 5/6 really. And then we'd subtract the 4 and get x equals negative 4 plus or minus 5 square root 2 as our two answers. So to kind of recap this, our first step is to rewrite it towards ax squared plus bx equals c. All of our x's are on one side, the constants or regular numbers are on the other. Then if we have a coefficient with the x squared, the ax squared is another number other than 1, then we have to divide every single term by that number to get it to be a 1x squared. This method only works if it's a 1x squared. Then we take half of our b term, square it, and add that to both sides. This is by far the weirdest step in this process, in my opinion, because it's something we've just never done before and it's so odd and random. But it will work 100% of the time. That's the neat part about it. Then we'll be able to factor this perfect square trinomial, where it's the x and then half of b. In this case, half of 8 was 4. Specifically, half of positive 8 was positive 4. And then we square root both sides and solve from there. So let's practice this on a few examples, and by a few I mean quite a few. So solve by completing the square and give all answers in simplest form, always giving answers in simplest form. So here we notice that this is a perfect square, but this is not, and so we could create completing the square, a perfect square trinomial, and we'll do this by subtracting 56 on both sides. So we get x squared minus 18x equals negative 56. Now you may notice I left an intentional blank here, because I know on my next step I'm adding something anyway to both sides. So I'm just going to go into plus blank and know that I'm going to be adding half of b being squared on both sides. So I note that half of negative 18 is negative 9. And if I square negative 9, I get 81. So I'm going to write 81 on both sides. And that's because if I square negative 9 times negative 9 is positive 81. Now I know the next step is going to factor as x, the variable, half of b, which is negative 9 in this case. You have to be careful here, matching this sign with this sign, because half of negative 18 is negative 9, equals 25, as we combine negative 56 and 81. And then we will go ahead and square root both sides here. And we'll get x minus 9 equals positive negative 5. And now we can go ahead and split the equations. We must split the equations in order to continue solving this, because we can actually combine 9 and 5 as well as 9 and negative 5. So we have x minus 9 equals 5. The arrow didn't want to write for some reason. And x minus 9 equals negative 5. And as we add 9 to both sides, we get 14 as well as 4. Number 4. It is already in the ax squared plus bx equals c form. However, a is not by itself, so we divide every single thing by whatever a is, in this case 2. And we get x squared minus 16x equals negative 15. I'm intentionally leaving that plus blank space, because I know I'm going to be putting something there. In this case, it's half of negative 16 squared, so half of negative 16 is negative 8. I square that, and I get positive 64. I now go ahead and factor it in this next step, where I do x, half of b, x minus 8 quantity squared, equals 49. Sorry, that's not 49, my apologies. I said half of b squared would be negative 8 squared, but I messed something up very big here. I messed up that this should not have been a negative 16x in the green. That should have been a negative 8x. My apologies here. And I'm still going to leave that spot for the plus blank, actually. That's better. And so now as I have negative 8 divided by 2, I get negative 4. Square that and I get 16. Now as I factor the left side, I get x minus 4 quantity squared. On the right side, I get 1. I square root both sides, and I get x minus 4 equals positive negative 1. I now have to make both cases here, where I'd have x minus 4 equals 1, oopsie, and x minus 4 equals negative 1. I add 4 to both sides of each equation, and I get x equals 5 and x equals 3. Moving on to number 5, 4x squared minus 8x equals negative 3. So this is already in the form form or organization we want. However, we still need to divide everything by 4. And I get x squared minus 2x. I actually divided it that time. Equals negative 3 over 4. We have a fraction there, but that's okay. Fractions are numbers too. I add blank on each side, and inside that, or on that blank, I'm going to be doing half of b squared, which is half of negative 2 squared, and half of negative 2 is negative 1. I square that, and I get positive 1. The left side factors into x, and then half my b, so x minus 1 squared equals 1/4. When I combine negative 3/4 and 1/4. I go ahead and square root both sides, and as I square root 1/4, I end up getting positive negative 1/2, because square root of 1 is 1, square root of 4 is 2. I now will split this, because I can actually combine 1 and positive negative 1/2. So I have x minus 1 equals 1/2, and x minus 1 equals negative 1/2. As I add 1/2 to both sides, I end up getting x equals 3/2, or 1.5, or 1.5, and x equals 1/2, or 0.5. Number 6, I need to subtract 8 in order to get it in the order we want. And so I subtract 8 and I get 3x squared plus 10x equals negative 8. Notice I didn't go ahead and leave the blank there because I'm going to be dividing everything by 3 anyway. And we end up getting x squared plus 10 over 3x, kind of messy, equals negative 8 over 3. And we're not going to be saying, oh no, we can't do it. We'll just have it be messy. And so 10 over 3, if we divide by 2, well, remember we can always multiply by a reciprocal, so I'll multiply by 1/2 the reciprocal of 2. That's the same thing as dividing by 2. We end up getting 10 over 6. And if we square, and that actually reduces here, so let's go ahead and reduce that to make our life a little bit easier before we square it. So when we square, to reduce this rather, would end up giving us 5 over 3. And now, as we square 5 over 3, we do 5 times 5 over 3 times 3. This is quite a lot here. We end up getting 25 over 9. Now we can factor this left-hand side into x plus your half b, which in this case I put plus because my 10/3 is positive, so half of that is positive. And that was 10 over 6, or 5/3. Quantity squared equals on the right. You have to get common denominators. Common denominator would be 9, so this becomes, as we multiply by 3, negative 24 over 9, and that gives us 1 over 9. Now we square root both sides, and we get x plus 5 over 3 equals positive or negative 1 over 9. Now we will split this because we can actually combine these, albeit a little bit messily. X plus 5/3 equals 1 over 9. X plus 5/3 equals negative 1 over 9. So on the left, as we subtract 5/3 and get common denominators, this will end up being x equals 1/9 minus 15 over 9. And the other one ends up being x equals negative 1/9 minus 15 over 9. And combining these, we end up getting 14 over 9. I think I did something wrong here. Oh, silly me, silly me, silly me. I keep making mistakes here, and I apologize deeply for that. Alright, this should never have been 1 over 9 in the green. That should have been 1 over 3. That's important because the square root of 9 is 3. And that's going to matter here on these problems because now as we have 1/3 here, we no longer have to worry about common denominators. The denominators are already, well, common. So as we subtract 5/3 on both sides, we get negative 4/3. And then over here we get negative 6/3, which is just negative 2. Number 7 here. These, we notice, starting with number 7, are going to be irrational solutions. So we will not have perfect squares on the right-hand side, and that's okay. It actually, in some ways, might make our life easier for some of us, because then we don't have to worry about doing this whole splitting business, because we won't be able to actually combine them. We'll just have to simplify a square root instead, which some of us might prefer and some of us might not. Regardless, our steps are the same, so we have to get it into being ax squared plus bx equals c. And even though we have a number on the right-hand side, there's still a constant on the left-hand side that we have to move by adding 21. So we get x squared plus 16x, and I'm going to go ahead and make my room for the plus blank as well, equals 16. I do not have to divide by anything since a is already 1, so 1x squared. And on the blank, I'm going to do 16 over 2. Half of that is 8, positive 8. And I square that and I get 64. The left side factors into x plus 8 quantity squared, while the right side just turns into 80. Now, as I square root both sides, I get x plus 8 equals positive negative square root of 80, which I will go ahead and start reducing into, or simplifying into, square root of 16 times square root of 5. Knowing that's positive negative 4 square root 5. Now I must add 8 to both sides, or excuse me, subtract 8 from both sides, and I get negative 8 plus or minus 4 square root 5 as my answers. Number 8 here, we'll divide everything by 3 because it's already in the right order, but we don't have an a of 1, we have an a of 3. And this method only works when a is 1, so we get x squared minus 10x equals 33, intentionally leaving this blank for my plus blank that I'm going to be filling in by doing half of negative 10 is negative 5, square that and I get positive 25. Factor the left-hand side and I get x minus 5 quantity squared. Remember, always the half of b going in the second half of this parentheses. And that would equal 58. My apologies. This should be a 48 because this should never have been 33. Making mistakes all over the place today. This was 23. And now we will then square root both sides and get x minus 5 equals positive negative square root of 48, which is square root of 16 times square root of 3. And that's x minus 5 equals positive negative 4 square root of 3. So add the 5 to both sides, and we get 5 plus or minus 4 square root of 3. Moving on to the next page. We've got some more examples. Whoop whoop. Example number 9, more irrational solutions where they're not going to be perfect squares on the right-hand side. And so we're going to add 31 here, and we get x squared minus 6x plus blank equals 31 plus blank. Half of negative 6 is negative 3. Square that and I get positive 9, which I add to both sides. Factor the left-hand side and I get x, bringing back the half of b is negative 3. Quantity squared, and that equals 40. Actually, this time I actually put the right number on this one. Good for me. Square root both sides, and I get x minus 3 equals positive negative square root of 4 times square root of 10, starting the simplifying process. And this is x minus 3 equals positive negative 2 square root of 10, which, as I go ahead and add 3 to both sides, it gives me x equals 3 plus or minus 2 square root 10. On number 10, we have to first add 57 and then divide by 2 to every single thing. Now, you could technically divide by 2 early, however, you're going to get 2 fractions here, which would end up becoming a non-fraction after you combine or reduce, but it's going to cause you a little more pain in the meantime. So I'm just going to go ahead and combine the other side by adding 57 and getting the number 144. Then as I divide everything by 2, I get that 70-something I was talking about a moment ago, where I get x squared plus 2x equals 72, leaving enough room for my plus blank, knowing I'll need it. And if I take 2 and divide by 1, I get 1. I square that, I get 1. And now I can factor my left-hand side into x plus 1 quantity squared, because this is a positive 2, half is positive 1, and that equals 73. As I go ahead and square root both sides, my iPad is not wanting to cooperate here. There we go. As I square root both sides, I get x plus 1 equals positive negative square root of 73. Now notice I didn't start simplifying this because you actually can't simplify the square root of 73 at all. No perfect squares go into 73. And because of that, we just go ahead and subtract the 1, and we get negative 1 plus or minus the square root of 73. Starting with number 11 through 14, we're going to get complex solutions, which technically all of these solutions have been complex because every number is a complex number. However, these are specifically complex because you're going to have imaginary solutions. These are going to get square roots of negative numbers. So on number 11, we'll start by subtracting 43, and I get x squared plus 12x equals negative 43, adding in the plus blank. And half of 12 is 6. Square the 6, and I get 36. And this will factor in on the left side to x plus 6 quantity squared, and on the right side it'll be negative 7. So notice here's the negative, and we're going to be square rooting, and getting x plus 6 equals positive negative square root negative 1 times square root 7. Square root of 7 cannot simplify any further, so we'll call this x plus 6 equals positive negative I square root 7. Then we can subtract 6 and get negative 6 plus or minus I square root 7 as our two complex solutions. Number 12, x squared minus 18x plus 97. We first start by subtracting the 97, and I get x squared minus 18x, put the plus blank down, knowing I'll need it, equals negative 97, once again, plus blank. And as I take negative 18 and divide by 2, I get negative 9. I square that and I get positive 81. The left-hand side will factor into x minus 9 quantity squared, the half of the negative 18 being negative 9, equaling negative 16. I go ahead and square root both sides, and I get x minus 9 equals positive or negative square root negative 1 times square root 16, knowing that the square root of 16 is going to be 4, so I'll have positive negative 4i, wanting to put the 4 before the I. Then we're going to add 9. We can't add 9 to 4i though, so we just put 9 plus or minus 4i and write the 9 before the plus or minus. Moving on to number 13. This time we must divide everything by 4, but also actually we need to rearrange. So notice even though we have two things on the left, one thing on the right, it's the wrong two things on the left and the wrong thing on the right. So you could start by dividing since we're not going to be combining any like terms, or you can start by adding, subtracting. I'm going to start by subtracting on both sides. So I'm going to subtract 16x on both sides, get 4x squared minus 16x. And I'm actually going to go at the same time subtract 76 and get negative 76. And so I subtracted 76 from both sides. I subtracted 16x from both sides, and this was my result. Now I will go ahead and divide everything by 4 and get x squared minus 4x equals, let me leave room for the plus blank, equals negative 19. Then I will go ahead and put the plus blank, knowing that half of negative 4 is negative 2. So we should get positive 2, and then this is the negative 2 because we divided by 2. And then I square that and I get positive 4. I factor the left-hand side though, and I get x minus 2 quantity squared. And on the right-hand side, I get negative 15. So I go ahead and square root both sides, and I get x minus 2 equals positive negative square root negative 1 times square root of 15. Square root of 15 not simplifying at all. Then I'm going to add 2 to both sides. I've got x equals 2 plus or minus I times the square root of 15. Number 14, we have to subtract 80 on both sides in order to get this in the correct order we want. And we get 3x squared minus 6x equals negative 84. Notice I didn't bother writing the plus blank yet because I still need to divide by 3 on everything, to everything. And I get x squared minus 2x equals negative 28. I actually wrote the right number this time as well, which I've been messing that up before. Put the plus blank on each side, knowing I'll need it. Negative 2 divided by 2, the b divided by 2 is negative 1. I square that and I get positive 1. I factor the left-hand side and it becomes x minus 1 quantity squared, always the half of b over here, again, as I'll keep mentioning. And we get that equal to negative 27. I square root both sides under the square, and I get x minus 1 equals positive and negative. Square root negative 1 times square root 9 times square root 3. And that's x minus 1 equals 3i, my apologies, plus or minus 3i square root 3. Now I go ahead and add 1 to both sides. Cannot combine it with the 3i square root 3 though, so I just call it 1 plus or minus 3i square root 3. And that wraps up Algebra 2, Section 4.7.